The Harley-Davidson CVO Road Glide is getting another update. Last time we mainly talked about the suspension. Today it's all about the engine. And if you're curious to find out what's been done here, stay tuned, you're about to find out more. Welcome back to another episode of our RaceLab. Today's topic is once again the CVO Road Glide from Harley-Davidson. Last time we focused mainly on the suspension and suspension modifications. This time it's all about the engine. We know that Harley-Davidson has put a lot of effort into squeezing out more horsepower here to give the power plant a real performance boost. Not just for the laid-back cruiser rider, but also for those who want to push things a bit further. Even if this CVO Road Glide isn't exactly built for racetrack use and is clearly aimed more at relaxed cruising, the dedicated Harley rider still wants to tap into more potential. And especially nowadays, when 200 horsepower bikes are available pretty much everywhere as standard, there is also a desire to step things up in this segment. And that's exactly what's been done. The Milwaukee-Eight has been taken another step forward. Displacement has been increased. On the CVO, we're now at 121 cubic inches, which is just under 2 liters of displacement. That's a proper engine size. And naturally, they've worked to improve the performance as well. Let's take a quick look at how they've done that. As we've come to expect from Harley-Davidson, they follow their own path when it comes to engines. Not only do they still offer the classic V-Twin design, just like in Harley's early days, but the engine's overall layout has also stayed true to those roots. Harley-Davidson's goal in the cruising segment has always been to deliver loads of torque and solid power from low revs. And thus, the easiest way to achieve that is with a long-stroke engine layout. But that doesn't always come without drawbacks. Especially when it comes to achieving higher output, this concept isn't always ideal. Why? Because long-stroke engines don't allow for particularly high revs. Why is that? Why can't you get high RPM from this setup? The reason lies in piston speed. You can imagine, the longer the stroke, the greater the distance the piston has to travel from top dead center to bottom dead center. And at the same RPM, an engine with twice the stroke also has roughly twice the piston speed. And that quickly brings you up against certain limitations, physical limits based on component strengths and engineering tolerances that simply can't be exceeded. Looking more closely at the CVO, we've got a stroke of 117 mm and a piston diameter of 103 mm. So we can see that the stroke is clearly longer than the bore diameter. And that's quite an unusual approach, because most motorcycle manufacturers who aim to generate more power typically go in the opposite direction. They tend to use shorter strokes with larger pistons, because that allows the engine to rev higher. Larger pistons and therefore larger bore diameters also make it possible to fit bigger valves, which at higher revs help improve cylinder filling and reduce airflow resistance on both intake and exhaust. And just how far Harley-Davidson deviates from conventional engine design becomes clear when we do a direct comparison. Take the Super Duke for example. It has a maximum stroke of 71 mm, so massively shorter. And although the total displacement is smaller, we're talking just over 1300 cubic centimeters on the Super Duke compared to almost 2 liters on the CVO, the piston diameter tells the story. The Super Duke runs a 71 mm stroke with a 110 mm bore, so a piston diameter of 110 mm. That alone shows the completely different engine philosophies. The Super Duke, with its short stroke and large bore, can rev much higher and produce more peak power as a result. Harley-Davidson, on the other hand, is all about low-end torque, and they've really nailed that. The CVO delivers its maximum torque of 183 Nm at just 3,500 RPM. That's impressive, considering that idle sits at around 1000 RPM, meaning you've already got strong torque just above idle, exactly what you want in the cruising segment. But if you want to increase power on top of that, there's really only one way to go with this engine concept: more displacement. And that's the reason why Harley-Davidson, true to its history, has continued building bigger engines over time in order to meet the demand for more power, all while sticking to their core design of the large displacement V-Twin. But this V-Twin engine layout actually has one major advantage. You can build engines with a lot of displacement while still keeping them fairly narrow. Since the V-Twin has two cylinders arranged in line, you can increase the displacement significantly without the overall width getting out of hand. If you to do the same with an inline four-cylinder, say build it up to 2 liters, you'd end up with a really wide engine block. And that's just not something you can fit neatly into this kind of motorcycle. So Harley has very deliberately focused on its core customer base, riders who want that typical chopper-style cruising experience at low revs with loads of torque. Now, if we do another comparison with current high-performance engines, like the ones used in today's superbike, they're running at engine speeds well beyond 15,000 revolutions per minute, even in standard production bikes. That was unthinkable 10 years ago. Back then, only highly tuned race engines could hit those kinds of revs. Now it's practically the norm. But that's only possible because these bikes use extremely short-stroke engine designs. Just to give you a feel for it, the Harley CVO has a stroke of 117 mm. Compare that to something like a Fireblade engine, which doesn't even have 50 mm of stroke. And that's exactly what allows you to reach those insane revs. So these fundamentally different design approaches are the reason Harley-Davidson can only really increase power through more displacement. And that's exactly what we've seen over the last few years. So Harley has really continued drawing from the same playbook here, gradually increasing displacement in order to boost performance. Of course, this kind of large displacement, long-stroke V-twin layout also comes with some downsides. It's not just that the engine can't rev very high, you also get more vibration. That's simply because a motor with a long stroke tends to run a bit rougher. With the layout Harley-Davidson has chosen and has historically stuck with in its engine designs, there are both pros and cons. The advantages are obvious. For typical cruiser use, you get the right kind of power delivery from low down with strong torque. But once you get higher up in the rev range, things start to feel a bit sluggish. That's just a result of the engine concept itself, and it also brings along a few other small issues. The engine doesn't run quite as smoothly or evenly as, say, an inline-four. Especially with this long stroke setup, the engine tends to become a bit rough. I wouldn't call it unbalanced, but there are definitely more vibrations, particularly in certain RPM ranges. The only way to really compensate for that is with additional flywheel mass and rotational inertia. But that, in turn, tends to reduce power output a bit. Still, you need that to achieve some degree of smoothness in the engine's behavior. Another limitation of long-stroke designs is that you end up with relatively small piston diameters, which restricts how big the valves can be. And valve size plays a crucial role in proper cylinder filling. It's easier, of course, to use large bores and big pistons, which then allow you to fit larger valves as well. Despite all that, Harley has once again managed to optimize this engine layout specifically for its segment. We now get 117 horsepower at around 5,000 revolutions per minute and 183 Nm of torque at 3,500 revolutions. That's a decent bit more than the previous engine had, and since we wanted to know exactly how it performs, we put the bike on our dyno and took some proper measurements just to see whether the values Harley-Davidson promises in the brochure actually hold up. And when we look at the data, it's clear. Our dyno measures rear wheel output, both horsepower and torque, so it's only what gets to the wheel, not the engine itself. For engine figures, we'd need a full engine test bench. But here's what we got. Peak output at the rear wheel came in at 108 horsepower with torque at 167 Newton meters. That means we can definitely say this engine lives up to the claims in the spec sheet. Harley-Davidson quotes 117 horsepower, and that's always crankshaft output. That's generally the case for all vehicles. The power figures shown in brochures are always engine power measured at the crank, where the power is generated. On a chassis dyno like ours, we can only measure power at the rear wheel, and you always have to factor in significant drivetrain losses. So in this case, with 108 horsepower at the rear wheel and 117 at the engine, we can confidently say the bike delivers at least those 117 horsepower at the crank. You can easily account for around 10 horsepower in drivetrain losses on this type of motorcycle, so that power is definitely available to the rider. And if we look at the curve, you can clearly see, just like we mentioned earlier, that the maximum torque is already reached below 3,500 RPM. In fact, just above idle, somewhere around 1500 to 1700 RPM, we are already seeing 100 Newton meter of torque. And for a bike in this category, that's seriously impressive. If we take a closer look at the dyno graph now, we can clearly see that the engine, just as we discussed earlier, follows Harley-Davidson's philosophy, delivering very high torque at very low RPM. The peak torque of 167 Newton meter measured at the rear wheel is reached at just 3,500 revolutions per minute, and then gradually drops off towards the rev limiter at 5,500 revolutions. What's really impressive is that this engine already produces 160 Newton meter of torque at 1,700 RPM. That's just above idle speed. So you're getting nearly the full torque output barely off idle, which means this is an extremely torque-oriented engine. You can just cruise along smoothly, crack open the throttle at any time and immediately get that full surge of power. Another thing that stood out with this engine is that despite the increased displacement, the overall vibration level has actually gone down. They've clearly done a lot of work here in the component design and in how the engine runs to make the whole experience smoother, with less vibration being transmitted into the chassis. So now you can accelerate cleanly from idle without the engine becoming rough or delivering a choppy response. And the fact that Harley-Davidson is slowly edging closer to racetrack territory is something we've been seeing more and more of in recent years, and many of you might have already noticed. The Bagger Racing series, which has been around in the US for quite a while now, is starting to make its way over to Europe as well. And what we're seeing there are basically these exact bikes being used on track. The goal is to show that Harley-Davidson isn't just building bikes for the road and for cruising, but that with a few tweaks they can also hold their own on a racetrack. For the Bagger Racing series, this exact model, the Harley-Davidson Road Glide CVO, is used as the base bike, of course heavily tuned. The top machines in that series now push 200 horsepower and 280 Newton meter of torque, which is absolutely insane. That's obviously far beyond what the standard engine can do. To reach that level, they use extreme tuning components, titanium parts, special alloys, and ultra lightweight internals. That's when things really get serious. These bikes can hit speeds of up to 300 kilometers per hour on long straights. The suspension systems are, of course, completely overhauled, so it's fair to say that these race machines don't have much in common with the standard production bikes anymore. But the basic layout and character of the bike are still the same, and it just goes to show that with the right modifications you can absolutely take a machine like this onto a racetrack, provided you've got the rider to match, of course. And if you look ahead to the near future, we can see that the trend from the Bagger Racing series is slowly making its way from the US over to Europe. Starting in 2026, these race bikes and the series itself will appear at 6 MotoGP events in Europe, giving European fans a chance to see firsthand that you really can push these bikes hard on a racetrack. There'll be 6 selected rounds, each part of a MotoGP weekend, and they'll run 2 races per weekend, so 12 races in total. Some of them will even be broadcast, not on public TV, but via MotoGP's own streaming platform. So if you're interested in this kind of thing, you'll definitely find what you're looking for there. And for anyone who's curious, it's absolutely worth a watch. These are proper races, exciting and impressive. It's not like one rider just disappears off the front. The racing is usually tight, with riders staying in a pack for most of the race. And we've still got a lot planned with our CVO. We now know what's needed on the suspension side. We've taken a close look at the engine, and now, of course, we want to see how it all performs on the track. This isn't a fully built bagger racer, just a stock production bike with a few light modifications aimed at improving performance and track usability. And how it actually behaves on the racetrack and what kind of result we get from our entire tune-up, you'll find out in the next episode of the 1000 PS RaceLab.